Triangle ABC is an equilateral triangle. Construct three blue sides AD, BE, and CF so that they cut the sides of triangle in the same ratio 1 to K. Name the three intersection points as P, Q, and R. If the area of triangle ABC is double the area of triangle PQR, find the values of K. For convenience, we use the notation of square brackets for areas of triangles. Indeed, at the end of the video, you may be surprised that there are two possible values of K. Let's see how to solve it. First of all, because of rotational symmetry, these three red triangles have the same area. Let's call them X. By the same reason, these three yellow quadrilaterals also have equal area. We let them be Y. For the middle green triangle, the area is Z. Now, we make use of the given condition. The sum of areas of all parts is 3x plus 3y plus z, which is equal to 2 times z. So, z is equal to 3x plus 3y. What other tools can we use? Let's look at a very important geometric result. Consider two triangles with the same height h. Let's write down the formula of areas of the triangles. If we consider the ratio, then the 1 over 2 and h are cancelled out. So the ratio is equal to the base BD over the base CD. In other words, the area ratio is equal to the base ratio. We shall make use of this result 3 times. Now go back to the original figure. Let's look at these two larger triangles. Because they share the same height, so the area ratio is equal to 1 over k. That is 2x plus y over x plus 2y plus 3x plus 3y is equal to 1 over k. Cross multiply the equation. We put the y terms on the left and the x terms on the right. It becomes 5 minus k times y is equal to 2k minus 4 times x. Let's call this equation 1. Let's take a deeper look at this equation. Clearly, x and y must be positive because they are areas. What about the k terms? If 5 minus k is equal to 0, then 2k minus 4 should also be equal to 0. It means that k is equal to 5 and k is equal to 2 at the same time. This is impossible, so all the terms are non-zero. This is important in the steps later on. Next, we make use of the ratio for the second time. Construct the purple side CQ. Let's look at the red and purple triangles. Using the same method, the area of the purple triangle is equal to k times x. So the area of the blue triangle is equal to y minus kx. Alright, let's make use of the ratio for the third time. We focus on the side AC and two other triangles. Again, the ratio of the areas is equal to 1 over k. That is y minus kx plus x over 3x plus 3y plus y is equal to 1 over k. Cross multiply the equation and grouping the like terms, just like what we have done so far. It becomes k minus 4 times y is equal to k squared minus k plus 3 times x. Let's call this equation 2. We put the two equations together. Divide equation 2 by equation 1. Then we can get rid of the unknowns x and y. Because all the terms in equation 1 are non-zero, so everything looks good. Now cross multiply the equation again. We expand the left-hand side and the right-hand side like this. After simplifying the equation, we get k cubed minus 4k squared minus 4k plus 1 is equal to 0. Indeed, the cubic equation can be factorized. We group k cubed and 1 together and put the other two terms at the back. For the first two terms, it's factorized as k plus 1 times k squared minus k plus 1. For the last two terms, we take out the common factor 4k. Now, we have another common factor k plus 1 in the two groups. So the second bracket is k squared minus 5k plus 1. Then we get a quadratic equation, or k is equal to negative 1, which is rejected. the equation can be solved by quadratic formula. Putting all the values inside, we get k is equal to 5 plus or minus square root 21 over 2. What does it mean for two values of k? The first value is larger than 1, which is consistent with the figure. Actually, we can reflect it horizontally. Then the second value of k is for this new figure. It also satisfies the given conditions of areas. What a nice challenge, isn't it? Looking for more interesting geometry questions? Check out the next video right here on the screen. I will see you there.